Alrighty, so today we're looking at 4E, using tables for two-step experiments. So the key thing here is two-step experiments, okay? So that kind of means you do one thing and then you do a second thing, and then we're trying to find the probability of doing that first one and then the second one. So we use tables to help us. So tables are used to list the sample space for two-step experiments. Okay, sample space are like all of the outcomes. So all of the possibilities that you could get with the two experiments. All of the outcomes. Okay. So the next little bit, it says if replacement is allowed. So that kind of means, say you've got a bucket full of balls and you pull out a ball. Replacement means you can put that ball back in to repeat the second experiment, okay? So it means, then outcomes from each selection can be repeated. Okay, so if you pull out a red ball, you can put it back in, and then red is still an option you can choose when you pull out the next one. Sometimes in some questions, it'll say selections are made without replacement. Okay, so let's say, go back to that example. If I pulled out the red ball, it says you're not allowed to use replace, or you're not allowed to replace it. Then you put the red ball away, so that when you conduct that second experiment, red is no longer an option because you didn't put it back in. Okay, so it cannot be repeated. So, for example, we've got two selections are made from the digits 1, 2, and 3. Okay, so you've got the numbers 1, 2, and 3 to choose from, and you're going to choose two of them. So, with replacement, this one's with replacement. So you might choose a 1 and get another 1, okay? So that's an option. So we're listing, again, sample space up here. Okay, we're listing all of the outcomes in our table. So you could get a 1 and a 1, or you could get a 2 and then a 1, or a 3 and then a 1. So it's listing, these are all the outcomes, okay? And if you count them all, so 1, 2, 3, 4, 5, 6, 7, 8, 9, there are 9 outcomes. So it tells you how many possible outcomes there are. So that's a pretty basic one. This next one is without replacement. Let me use the other colour. So without replacement, okay, it says we cannot be repeated. Okay, so with this one, if you get a 1 with your first experiment, it means you cannot choose a 1 again because you're not replacing it. So that's why there's an X here. You cannot repeat the first one, okay? So just saying that again. So if you choose a 1 out of these numbers, you can't choose a 1 again because it says it's without replacement, okay? And again, you can count them all, but obviously don't include the ones with the X. And so there are 6 outcomes if you're doing this without replacement. It takes a while to get your head around, but it's really important to look at the question and see whether it says with or without replacement. So let's look at an example. Cool. So we've got a fair 6-sided die is rolled twice. List all of the outcomes using a table. Okay, so we're going to say, so we're rolling a dice twice. Okay, so our first roll, we're going to put here. So if we roll a dice, what are the outcomes? What could you get? You could get a 1, 2, 3, 4, 5, or a 6. Okay. And then down here is going to be our second roll. And on our second roll, again, we could either roll a 1, we could roll a 2 or a 3, a 4, 5, or a 6. Okay, now this table is meant to show us all of the outcomes, so all the possibilities that we could get. So I'm just going to use a different colour. So we could roll a 1 and then a 1, or we could roll a 2 and then a 1, or we could roll a 3 and then a 1. So this is going to take a really long time to write out. What I suggest though is everybody write this in their book so that whenever you get a question about this, which you do commonly, you've already got it written out so you can go back to it. You don't have to write it again. That would be my suggestion. So you're just going to have to bear with me. You guys, please put this in your book. Oops. So remembering the first number you write in your brackets is the number up the top, because that's our first roll. So this will be a 3 and then a 2, 4, 2, 5, 2, 6, 2. Okay, the next one, we've got a 1 and then a 3, 2, 3, 3, 3. Very tedious. Oops. Should be a 4, 3. 5, 3, 6, 3. Okay, we're halfway done. 1, 4. It is tedious, but it's really helpful to have a visual representation of our experiment. 2, 4, 3, 4, 4, 4, 5, 4, 6, 4. Almost there. 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6, 5. Oh, my hand's cramping. And last one. 1, 6, 2, 6, 3, 6, 4, 6, oops, 5, 6, 6, 6. Whew. All right. So that was A. Okay, B says state the total number of outcomes. So what we can do is look at our 2A table. Now you could go through and count every individual one of these brackets because they're all the different outcomes you can get. However, I know it's a table that's 6 by 6, so 6 times 6 is going to be 36. So there are 36 outcomes for rolling a dice twice. There are different, 36 different ways or options we could be rolling. Okay, C says find the probability of obtaining the outcome 1, 5. So the probability of getting a 1, 5 equals. So what you do is look at your table, okay, look at how many options, how many times can you roll a 1 and then a 5, okay. If I look through, there is only one option of getting a 1 and then a 5, which is here. Okay, so there is only one way to do that out of 36. That's not going to work. I might just leave it there, whatever. Okay. D, okay. Next one, probability of getting a double. So probability of a double. Okay, you look through and look at all the ones that you get a double for. So we've got, you could get a 1 and a 1, 2 and a 2, 3 and a 3, 4 and a 4, 5, 5, 6 and 6. So there are 6 different ways of rolling a double. Okay, so it's 6 out of 36. Okay, that simplifies to, well, 6 goes into 6 1 and 6 goes into 36 6 times. So there is a 1/6 chance of you rolling a double when you roll 2 dice. The next one, we're trying to find the probability, the sum of at least 10. So what that means is you roll a number, you roll your second number. Okay, if you were to add those together, we want to get a number that's less than 10. So how many of these options will give you less than 10? Okay, so what I will do here, let's use orange. Okay, so if you get a roll a 1 and a 1, you're going to get 2. Okay, if you get a 2 and a 1, you're going to get 3. 1 and 3, you're going to get a 4. 4, 4. Okay, so what I'm going to think is, well, a sum of at least 10. You obviously don't want any more than 10. So you're probably not going to want anything more than 5, 5, will you? Because 5 and 5 is 10. So, and you could get a 6 and a 4, which is a 10, or you could get a 4 and a 6, which is 10, added the sum. Okay, which means the rest of them are all going to be all less than 10. All of these are less than 10. Okay, so that means that there are 3 options. If you roll a 5 and a 6, or a 6 and a 5, or a 6 and a 6, okay, that means the sum is not going to be less than 10. Okay, so we don't want to count those. So if we take 3 away from 36, we're going to end up with 33 out of 36. Okay, so there are 36 ways that when you roll, you get a sum of at least 10. Oh, hang on, I've done that backwards. Sum of at least 10. So at least 10, so you want to get 10, 11, or 12. So sorry, let's quickly go back. Whoa, that was big. Sum of at least 10. So let's go back over here. I'm going to use green now, forget everything else. Oh, green's not going to work. Black. So this gives you 10. Okay. This gives you 11, and this one gives you 12. So there are all the ways that we can get a sum of at least 10, okay? Sorry, my language of what I read then was incorrect, so you've got to be really careful. Okay, so there are 1, 2, 3, 4, 5, 6 ways of getting a sum of at least 10, so 6 out of 36. Okay, and that simplifies to 1/6. So it's a 1/6 probability of getting a sum of at least 10. Got to be really careful with that wording. Gets me every time. Okay, and the probability of a sum not equal to 7 equals, so not equal to 7. So what we're going to do is find the how many outcomes you get where the sum is equal to 7, because it's going to be a lot quicker finding that. So if I look here, they've got a 6 and a 1, that's a 7. You get a 5 and then a 2, or a 4 and then a 3, 3 and a 4, 2 and a 5, or a 1 and a 6. Okay, so there are 1, 2, 3, 4, 5, 6 ways of getting a equal to 7, but this says not equal to 7. Okay, so we're going to take 6 away from 36. So that means we're left with 30 ways of not getting a sum equal to 7. Okay, and that equals 5 out of 6. All right, that was a long one, but the table you can see, it's really handy to have a visual representation to do your questions. Let's try to do one more, and then it's all up to you guys. So we're constructing a table without replacement, okay? Remember, without replacement, we are not, you can't have the same thing recurring, okay? So this one, we've got 2 letters are chosen from the word kick without replacement. So the first pick, okay, you could get a K, and then an I, and then a C, and a K. And then the second experiment, okay, the options are the same. So K, I, C, K. Okay, this is our table. Now our sample space. If we get a K, and then we pick out the K, you can't get that same K again. Okay, because we're not replacing it. We can't get it again. Okay, but the next one, you might pick out an I, and then get a K, so that's fine. You might pick out a C and then a K. You might pick out a K and then another K. Now the difference with this one, okay, see how this is the fourth K along here, that's the fourth K, and this is the first K. Okay, so they're different Ks. So if I picked out the fourth K, there's still a K in there that we could choose. Okay, so that's fine. Okay, so going back, you could get a K and then an I. Can you get an I and then an I? No, you can't. They cannot be repeated. Okay, so that's not going to work. But then you can get a C and then an I, and then you can get a K and then an I. K and C, you can get an I and a C. If I pull out a C, can I get C again? No, because it's without replacement. And then we've got a K and then a C. Last one, if I pull out the first K, can I get the fourth K? Yes. Okay, it's that same one as before. I could pull out an I and then the fourth K. I could get a C and then the K. If I pull out the fourth K, can I get the K, that same K again? No, I can't. So that needs to be an X. Okay, there's our table. That was A. B. We need to find the probability of obtaining the outcome. So the probability of getting a K and then a C. Okay, how many here gives us a K and then a C? Well, looking at my table, here's one. And then I've also got this one. Because there's two Ks, you would expect there'd be two. I can't see any more of getting a K first and then a C. So I can say that there are two out of how many are here? You can go through and count. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 2 out of 12, which is equivalent to 1/6. Okay, what's the probability of selecting two Ks? Okay, so looking again here, we get these two Ks. Any others? Here, there's another K here. So there are two ways you could get a K, two Ks, sorry. So again, that's going to be a 1/6. And last one, probability of getting a K and a C. Now the wording here is really important. A K and a C. So it doesn't really matter whether you get a K and then a C or a C and then a K. It doesn't matter. You just want one or the other. So you need to go through and count how many of these have a K and a C. Okay, so that's got a K and a C. That's got a K and a C, K and a C, K and a C. That's it. So there is 4 out of 12, which is the same as a third. And that's it.